Alright, hey guys. So I am going to continue our discussion at the end of Thursday. So we started talking about how would we dilate a figure on an XY plane. So before we even get to that, I just want to take a moment and just refresh on what we did on Desmos. It's my first time using this, so I'm still trying to figure out some things. Hopefully you can see this well. Okay, so we look at the warm-up for the Desmo activity, and we examined 4 different type of machines, and we just made some sketches and just observe where's the center of dilation, what's the pre-image, what's the image, and what is the scale factor, and how can we see the scale factor in this picture without having to measure lengths of things. So this was machine 1, so I just made a dot right there, and then this was machine 2, I also made a dot right there, and machine 3. So I just want you to stop the video and just think about what is the scale factor here. Where's the center of dilation, where's the pre-image, and where's the image? Okay, so as you remember, this right here, this dot, that's stationary, that's not moving, this is our center of dilation, and the darker color was our pre-image, and the lighter color was our image. So in machine 1, we can see that the scale factor here is 2, and I'm just going to draw some line here to kind of remind us why we can see the scale factor as being 2. Okay, so as you can see, the distance from the center of dilation to the pre-image, if we consider as this distance right here that's dark as a whole, then the distance from the center of dilation to the image is twice as much as that whole distance. That's why the scale factor here is 2. And when we go to machine 2, so again, I want you to take a second and just remind yourself what is the scale factor here for this machine. Okay, so again, I'm going to go ahead and draw some lines to help us see scale factor. So in class, we talked about how the scale factor here for machine 2 is 1.5 or 3.5 or 3 halves. And we can see that by looking at the distance from the center of dilation, which is this point, to the pre-image. So if we consider the distance from the center of dilation to the pre-image as a whole, then the distance from the center of dilation to the image is 1.5 times this whole right here. And I don't know if you guys remember, I'm going to try my best to do this, but we saw 1.5 by just looking at this distance right here that's kind of light, and we can see that 2 of them can fit into this dark one right here. So you can consider this whole entire distance as being partitioned to 3 different parts. And so we can see that the distance from the center of dilation to the pre-image was 1 whole, and the distance from the center of dilation to the image was 1/2 more than that. So the whole total distance from the center of dilation to the pre-image was 1.5 times that whole distance right here from the center of dilation to the pre-image. And then again, when we go to machine 3, so again, take a second to remind yourself what is the scale factor here. Okay, so when we look at machine 3, let's go ahead and draw some lines. So again, this was our center of dilation, and this right here was our pre-image, and this was our image. So the scale factor here is 1/2, and we can see that by just again looking at the distance from the center of dilation to the pre-image. So we consider that distance as one whole, so this whole distance right here as one whole, then the distance from the center of dilation to the image, which is right here, is half of that whole distance right there. Okay, so when we got to the end of this activity, when we look at 4 different pictures and we had to decide which one was the broken dilation, you guys remember that a lot of you guys picked this one in the corner, and the reason why this is a broken dilation is because the line connecting the center of dilation, which is A, to B, which is our pre-image, to C, which is our image, this line right here is not one straight line. It's actually 2 straight lines. So from A to B is one line and B to C is a different line. Whereas we know in an actual dilation, in a perfect dilation, the line connecting the center of dilation to the image and pre-image should form one straight line, as it is in this example right here. And then these 2 were in center of dilations, or they were broken dilation because the shape, this one is a pentagon that becomes a hexagon, and we know that the shape should not change from pentagon to hexagon. And right here in this one, we have a rectangle that was dilated into a quadrilateral that is not a rectangle. So we know that when we are dilating, the shape should stay, so if it's a rectangle originally, it should still be a rectangle, even if it's getting larger or smaller. Okay, so let's apply what we did there to this example that we have. So our goal right now is trying to dilate this rectangle right here by a scale factor of 3 using this point as a center of dilation. So again, from our broken dilation activity, we saw that the line that connects the center of dilation to the pre-image and the image should they should all lie on the same line. So we know that D prime is going to be somewhere on this line, and our next job is to figure out how we're going to find that point D prime. Okay, so now we look back, now we pay attention to the distance. So from the warm-up of the decimal activity, we saw that if the scale factor was 2, then the distance from the center to the pre-image, or let's say the center to the image, is twice as much as the distance from the center to the pre-image. So that means if we're dilating this by a scale factor of 3, then that means the distance from the center to our image, which is somewhere on this line, should be 3 times as much as the distance from the center to the pre-image. So that means let's first figure out what is the distance from the center of dilation to our pre-image. So we can see that the center is right here, and our pre-image, which is, we're just looking at point D for now, going from the center to point D, we must go over right 2, up 3. So if we want the distance from the center to the image, which is D prime, to be 3 times as much as this, so instead of going over just 2, we're going to go over 3 times as much as that. So we're going to go over, so 3 times as much as 2, 3 times 2 is 6, so we're going to go over 6 to the left. So 1, 2, 3, 4, 5, 6, which puts us right here. And we know that going from the center to D, we need to go up 3, but we want the distance from center to D prime to be 3 times that. So instead of going just up 3, we're going to go 3 times as much as that. So that will give us a distance of 9. So we're going to stop. So we stopped right here last time, so we're going to go up 9 from here. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And so our point is going to be right there. So this is D prime. Let's just rename this so it's not confusing. Trying to remember. Oh, there it is. Okay, so let's name this D prime. Okay, so that's where D prime is going to be. And I'm going to go ahead and hide this line so that it doesn't get too clunky. Okay, so next let's go ahead and find where C prime is going to be. So again, we know that C prime, C, and the center of dilation should all lie on the same line. So that means point C prime is going to be somewhere on this line. Now we need to figure out exactly where. So going from the center to C, we see that we need to go right 2 and up 1. So that means since we're trying to dilate this rectangle 3 times as big, we need to go 3 times that distance. So instead of just going over right 2, we're going to go over 3 times as much as that. So that means we need to go to the left 6. 1, 2, 3, 4, 5, 6. And we went up 1 from the center to get to C. So it means we need to go 3 times as much as that. So that means we need to go up 3 from here. So there is our C prime. And again, let's rename this to C prime. Okay, and let's go ahead and hide this line. Okay, so that's where C prime is going to be.
So now let's go ahead and find where B prime is going to be. So again, we know that the center of B and B prime should all lay on the same line. So we know that I suppose B prime is going to be somewhere on this line. And again, we're dilated by a scale factor of 3. So we're going to see how, we're going to figure out for ourselves the distance from the center of dilation to B first, which is our pre-image. So that's going over 1, 2, 3, 4, 5, and up 1. So we're going left 5, up 1. So since we are dilating by 3, and I think we have to move this over, we're going to go 3 times as much as that distance. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And we went up 1, but we need to go 3 times as much as 1. So that means we need to go up 3. So 1, 2, 3. So our B prime is going to be right there. Oops, I didn't mean to do that. So we need to rename this to B prime.
So now I want you guys to try on your own and see if you can find where A prime is going to be. So we have D prime, C prime, B prime. Okay, so again, it reapplies the same process. And this time I'm going to try our little line. So we're just going to look at the distance from the center to A, which is our pre-image. So I'm going 1, 2, 3, 4, 5 over and up 3. So dilating by a scale factor of 3 would mean we need to go 3 times as much as that distance. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And we're going to go 3 times as much as before, so that means we need to go up 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. That puts A prime right there. So when we connect all these 4 points together, we should see a dilated image by a factor of 3. There was an easier way to find A prime. So take a second to think about that second method of finding A prime. So another way that we could have done this is, since we had, so before we had, we didn't have A prime, but we had all the other points. And since this is a rectangle, and we know that we're dilating by a scale factor of 3, we know that the distance from A to D is 3. So that means the distance from A prime to D prime is going to be 3 times as much as that, which is 9. So we can just count 9 over from D prime. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and put A prime right there. And that would have worked. All right, and so that's how you would dilate a figure on an XY coordinate, and it would work the same way even if the scale factor is less than 1. So go ahead and try to see if you can work on this by yourself with the IXL activity.